If you read the highlighted sentence, it says, understand how the movement and position of Earth affects the life on Earth. Well, what we're going to start talking about is how does Earth in space work? How does that affect us? Okay, we're going to look at Earth being in space. I want you to write down some questions of the week in your science journal, but leave a blank space in between, and we're going to come back and answer these. All right, so write these questions down. Now you're going to make some hypotheses. All right, don't worry, they can be incorrect. I just want to see what you guys already know. So, write down your personal opinion about the following question. What is the difference between rotate and revolve? Well, rotate is, got a friend, rotate is spinning, and orbiting or revolving is to go around. So two words that sometimes get mixed up with each other. This is rotating, that is revolving. Earth is not the only thing that's rotating and revolving. So Earth does rotate, it does revolve, but the moon is also rotating. The moon is spinning as it revolves around Earth. The sun is spinning as it revolves around the center of our galaxy. So almost everything that's in space is not only rotating, but it's also revolving around something with much more gravity. Second hypothesis, how does the rotation affect the planet? What does this motion here do to the planet? How does it affect things living on the planet? Third hypothesis, how does this motion, its revolution, affect the planet? What does that do to the planet itself or to things that are living on the planet? So Derek has a YouTube channel called Veritasium, where he goes out often and interviews people with basic science questions, kind of to see what most people know or think. Here's one of his videos.
Why do we get the seasons?
The seasons? Because of the atmosphere?
To be honest with you, that's a very easy question to answer now. We really don't get seasons anymore because of global warming. I think there was a time when I was a child where we definitely had 4 seasons, but I think now we get summer, 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 and a little bit of winter in Australia.
Is it to do with the Earth's turning and the equator? The 4 seasons?
You mean like summer and winter and autumn and spring?
Doesn't it come from where we are around the sun? And at that stage, that's the season that we're in.
I think the position of the Earth, depending on the sun, it's like if the Earth is standing other positions to the Earth, and there's winter, summer, and in the between there's autumn and spring.
Because the Earth rotates on an axis, right? And I think so. It goes around on an axis.
Well, obviously the Earth isn't like spinning like that. It's sort of like on an angle because of the axis of the Earth rotating. The Earth rotating around its axis.
Yeah, what does the axis do?
It seems you further and closer to the sun.
For example, now the southern part, Australia is winter now, and Europe is in the summer season, and then the north side of the Earth is standing more close to the sun, and the south side is like far away from that.
It's because the Earth is at I think it's a 22-degree tilt or something like that. So as it goes around the sun, that means that either the north or the southern hemisphere is close to the sun, so that things are hotter or colder.
When the Earth goes around the sun, it's not a circle; it's an ellipse. So we have different distance to the sun.
So therefore, the further the sun is away, the colder it is in a country.
Like it's because it's like an oval. It's not like perfectly circle. It's like so the sun comes closer this way and then out further, gets closer.
The elliptical pattern of the Earth and the distance from closer to the sun in summer and the furthest away from it in the winter.
Sometimes the sun is actually glancing the surface of the Earth in certain regions, and other times it's square on, like perpendicular.
Well, basically, the sun's rays are more oblique at certain times of the year than at others.
I think it's because of how the sun rays are like hitting. When they hit at an angle, it doesn't get that hot.
So what does cause our seasons? Why do we have summertime, wintertime? Why does it get cold and then hot? Why are they flip-flopped in the northern and southern hemisphere? What causes all of that?
I'm sure many of you notice seasonal changes year after year. Come to think of it, you're probably so used to them you don't even think about them anymore. Unless they're, you know, in your way or something. Those types of changes are different depending on where you live. There isn't a whole lot of variation in temperature in the tropics. It's warm sometimes and hot other times. It never really gets cold. It makes more sense to discuss a dry season and a rainy season. The Arctic areas are mostly just cold all the time. Parts can even go months straight without any sunlight. In the temperate areas, though, you basically have 4 seasons. Spring, summer, fall, and winter. Plants bloom in the spring, it gets hot in the summer, trees lose their leaves in the fall, and it gets cold in the winter. But why? Why does this happen? Oh, it's because Earth is closer to the sun in the summer, right? Oh, no. Actually, here at 42 degrees north latitude, we're further away from the sun in the summer. 3.3% further away. Wrap your mind around that. So why is it so much colder in the winter? Because the Earth is tilted. It doesn't really matter how far away the tilt has moved us from the sun either. Again, at 42 degrees north latitude, I'm only tilted about 2,100 miles further away from the sun in the winter. That might seem like a lot, but the Earth is 93 million miles from the sun. So 2,100 miles is only about 0.001%, which is much less than the 3.3% we get from orbiting the sun. And we already said that didn't matter. What the tilt of the Earth does is it changes the angle at which light hits the ground. There's a shallower angle in the winter, so the light is just sort of grazing the ground. In the summer, though, the angle is steeper, causing the light to hit the ground more directly. What does that have to do with anything? Doesn't the Earth get the same amount of light regardless? That's actually a really good question. The energy you get from the sun is not the same as the energy the Earth gets from the sun. Energy is something you receive as an amount, kind of like money. First, you want to know how often you're getting it. Knowing you're getting $1,000 isn't very useful. Is it 1,000 per year? 1,000 per month? 1,000 per week? 1,000 per second? 1,000 per second would be pretty awesome, actually. It matters. When it comes to energy, we usually measure it per second, which is where the watt comes from. It also matters how it's being distributed. Is it just you receiving $1 per second? Or your entire town? If it's your entire town, then you are probably receiving less than a penny. When it comes to energy, we usually measure per square meter. If we consider both of these things, then we'll be measuring joules per second per square meter, or watts per square meter. This is what we call intensity. Ignoring complicated things like clouds and other weather patterns, if the Earth were flat and facing the sun, there would be 1,365 watts per square meter hitting the surface of the Earth. Slap a simple atmosphere in there, and that goes down to about 1,000 watts per square meter, because the atmosphere absorbs some of the light on its way in. Fortunately, the Earth isn't flat. On the winter solstice, you are tilted as far away from the sun as possible, which means the light is spread out over the widest area. Less energy per square meter means the intensity is lower. On the summer solstice, you're tilted as far toward the sun as you ever will be. So the sunlight you're getting is more direct. More energy per square meter means the intensity is higher. The ultimate point to this is that while the Earth is always receiving the same amount of energy from the sun, the summer people are getting more of it than the winter people.
So what we just figured out is that the sun's rays in the summertime versus the wintertime don't hit Earth at the same angle. Okay? In the summertime, the sun's going to be much higher in the sky, shining more directly down onto Earth. Wintertime, it's going to be much less direct. It's the same amount of sun rays. If you take a look, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 sun rays are hitting in 1 square meter versus 5 sun rays hitting in 2 square meters in the wintertime. So because Earth is tilted towards the sun in the northern hemisphere in the summertime, the sunlight's hitting us much more directly. When we're on the other side of our orbit, however, and the northern hemisphere is now facing kind of tilted away from the sun, well, now the sun rays are hitting much less directly and they are more spread out. So if you have the same amount of rays being spread out over more area, they're not going to heat it up as much. The seasons have nothing to do with how far away Earth is from the sun. Because in the summertime, in the northern hemisphere where it's hottest, we're farthest away from the sun. When it's winter time for us, we're close to the sun because we go around the sun in an ellipse. So if it had anything to do with distance, it would be the other way around. Hot when we're close, cold when we're far. But this is actually summertime. This is when we're the hottest, when we're farthest away. So it has nothing to do with distance. It has to do with the angle of light. Is it hitting directly or is it hitting indirectly? We average about 93 million miles away. That's 1 AU. And the distance varies by about 3%. But we are closest to the sun at what's called a perihelion. That's a point in the orbit of anything that's orbiting where it's closest. The perihelion is in January. We are closest to the sun in January. We are at aphelion, the farthest from the sun, in the middle of the summertime where it's the hottest. So where we are farthest away from the sun, it's the hottest time of year for us in the northern hemisphere. When we're closest to the sun, it's the coldest time of year. It has nothing to do with how close or far away. It's the tilt of the Earth means that the sun rays are either going to be hitting very directly or very indirectly. The sun can only be directly overhead if you are within what's called the Tropic of Cancer and the Tropic of Capricorn lines. Okay, the Tropic of Cancer and Capricorn are imaginary lines on the surface of Earth. And if you are standing on the equator and the Earth was not tilted, the sun would be directly overhead. Because you'd be a little person standing right here and your head would be directly under the sun. But we're tilted. So now the person who's has the sun directly overhead is standing right here. All right, that's going to be the Tropic of Cancer. And then in the wintertime, the person that has the sun directly overhead on this little Earth's butt is right here. That's what's called the Tropic of Capricorn. You can never have the sun directly overhead if you're at the North Pole, because the sun's never going to be up here. So the Tropic of Cancer and the Tropic of Capricorn are the only, or somewhere in between, are the only places on Earth where you can have the sun directly overhead. If we were like this, then you could stand right on the equator and the sun would be directly overhead. All right. So this is what's known as being at an equinox, when somebody on the equator has the sun overhead, or in this configuration. This is the winter solstice for us. This is going to be in the northern hemisphere. We're faced kind of away. This is the winter time. This is going to be the shortest day of the year. Now we're faced towards the sun. This is going to be the longest day of the year. If you've got sunlight hitting Earth, the sun is directly overhead this middle arrow. Because the Earth is tilted, somebody standing right here, you could be right in the middle of Mexico, somebody standing right here is going to have the sun directly overhead. All right, that happens on June 21st. That's the first day of summertime for us in the northern hemisphere. The winter, somebody in the southern hemisphere, so somebody down here in Brazil, is going to have the sun directly overhead. And they're going to be standing on the Tropic of Capricorn, and it's going to be wintertime for us up in the northern hemisphere. Because of the tilt of the Earth, there's going to be some places above 66 degrees north and 66 degrees south that either have constant daylight or constant darkness. So if you have, let's say you're standing at the North Pole and the sun is shining on you and the Earth is spinning, the sun is never going to go away, because the Earth is always going to be the North Pole is always going to be pointed at the sun. It'll always get some sunlight. You guys saw that the other day when you saw that there were some places that did not have nighttime. If you are at the North Pole during the summertime, the sun will never set below the horizon. It will always stay up. It will always be night. But let's say you're at the North Pole in the wintertime. Now the sun never gets to the North Pole and is constantly nighttime. That 66 degrees north and 66 degrees south both have very special names. They are the Arctic and Antarctic Circle. If you are above the Arctic Circle, there will be times of the year always daytime, always light, or always nighttime, always dark. This is a time-lapse photo in the Arctic Circle where the sun, it's setting, it never goes below the horizon. So it will never get nighttime. It'll never be dark. And then once it gets to its lowest point, it will start rising again. It's kind of weird to think about. It'll never be never have night. If you're standing at one of the poles, this is at the South Pole, the sun doesn't set or rise. It just stays right where it's at. It's kind of weird to think about. The sun never changes its height in the sky. It never sets, it never rises, just stays in the same spot. Seasons are reversed in the southern and northern hemisphere. Kind of makes sense, because if we are faced away so that we get very indirect light, the southern hemisphere is faced towards the sun, so they get very direct light. Winter for us, summer for them. Other side of the orbit, we have summer and winter for them. Finally, the last thing is something we've already learned. As Earth is rotating, the stars seem to spin in the night sky, and they go counterclockwise because of the direction of Earth's spin. And we've taken a look at some of those time-lapse photos, which I think are some of the coolest ones, and you get this. I would now like you guys in your science journal to sketch this little photograph picture thing that you see in front of you. So the first thing that I want you guys to label number 1, is the angle of Earth's tilt. Pick one of those little Earths and draw the angle that Earth is tilted at. Hopefully you know what that is from the FYI a few days ago. Then I want you to label Earth's axis. I would like you guys to label Earth's equator. And then figure out A, B, C, or D. Which one is the summer solstice? Remember what the summer solstice was. Summertime in the northern hemisphere. Label the winter solstice. The winter solstice is when it's wintertime in the northern hemisphere. A, is it this one, that one, or that one? Now label the direction of Earth's orbit. It orbits counterclockwise. Now that you know which one is the summer and the winter solstice, I want you to label the one that's the fall equinox. Keep in mind that Earth is orbiting counterclockwise, and now the one that is the spring equinox. Very fast little review. Precession is when the Earth's axis actually changes where it's pointing to. We mentioned a little bit with constellations, but if you can imagine spinning a top, it'll start to wobble. That's actually called the precession of the top. Earth does the same thing, and it has to do with the gravity of other planets. So it's just the change of the axis of any rotating body. Because Earth is rotating, it's going to have precession. Basically, the quick way to say it is that it changes the tilt of Earth's axis, but it happens over a very, very long time, like 26,000 years. So what I want you to do is make a hypothesis. How is precession going to influence the seasons? And is it going to be a fast or a slow change? I want you to answer this question. Why does Earth have seasons? Just tell me why, and then tell me the because, the reasoning that you came up with that answer. This is a video of people graduating from a little school. You may have heard of it. It's called Harvard. And these people are graduating from Harvard, which means they've already been there for 4 years. And they went out and they asked them why seasons happen.
Candidate in arts.
Despite a lifetime of the very best education, students in our classrooms are failing to learn science. Many of these students will graduate from college with the same scientific misconceptions that they had on entering grade school. To test how a lifetime of education affects our understanding of science, we asked these recent graduates some simple questions in astronomy. Consider, for example, that the causes of the seasons is a topic taught in every standard curriculum.
Okay, I think the seasons happens because as the Earth travels around the sun, it gets nearer to the sun, which produces warmer weather, and gets farther away, which produces colder weather, and hence the seasons.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the sun during the seasonal periods.
The Earth goes around the sun, and it gets hotter when we get closer to the sun, and it gets colder when we get farther away from the sun.
These graduates, like many of us, think of the Earth's orbit as a highly exaggerated ellipse. Even though the Earth's orbit is very nearly circular, with distance producing virtually no effect on the seasons, we carry with us the strong, incorrect belief that changing distance is responsible for the seasons.
I took physics, planetary motion, and relativity, and electromagnetism and waves.
I've never really had a scientific background whatsoever, and I got through school without having it. I've gotten very far without having it.
I had quite a bit of science in high school, yeah, through physics, first year, and 2 years of chemistry.
Regardless of their science education, 21 of the 23 randomly selected students, faculty, and alumni of Harvard University revealed misconceptions when asked to explain either the seasons or the phases of the moon.
When it's further away from the sun, then it gets colder.
The Earth's position interferes with the reflection of the sun against the moon.
So you guys can now say that you hopefully know more than people that have graduated from Harvard. I want you to go back and answer these 3 questions that you wrote down at the beginning. And we're done.